Good evening, friends. We'll start leak testing today. So, leak testing is the branch of non-destructive testing that concern the escape of entry of the liquids or gases from pressurized or into evacuated components or systems intended to hold these liquids. Leaking fluids, liquid or gas, can penetrate from inside a component or assembly to the outside or vice versa as a result of pressure differential between two regions or as a result of permeation through a somewhat extended barrier. Leak testing encompasses procedure for one or a combination of the following: locating, detecting, and pinpointing the leaks, determining the rate of leakage from one leak or from a system, monitoring for leak. Leak testing objective: to prevent the loss of costly material or energy, to prevent the contamination of the environment, to ensure component or system reliability. Terminology: leak: an actual through-wall discontinuity or passage through which a fluid flows or permeates. A leak is simply a special type of flow. Leakage: a fluid that has flowed through the leak. Leak rate: the amount of fluid passing through the leak per unit time under a given set conditions. Leak rate: the amount of fluid passing through the leak per unit time under given set of condition. Properly expressed in units of quantity or mass per unit of time. Minimum detectable leak: smallest hole or discrete passage that can be detected. Minimum detectable leak rate: the smallest detectable fluid flow rate. Measurement of leakage: a leak is measured by how much leakage it will pass under a given set of conditions. So, per liter per second, micron liters per second, atmospheric cubic centimeter per second. That is leakage rate. A real leak is an essentially localized leak, that is a discrete passage through which fluid may flow, crudely a hole. Such a leak may take the form of a tube, crack, or orifice, or like. As with flaws, all leaks are not the same. Leaks tend to grow over time. They tend to operate differently under different conditions of pressure and temperature. Virtual leaks involve the gradual disruption of gases from the surface or escape of gases from nearly sealed components within a vacuum system. It is not uncommon for vacuum system to have both real leaks and virtual leaks at the same time. To leak from the surface dissolved gases or nearly sealed components within a vacuum system. It is types of flow in leaks: permeation, the passage of a fluid inflow into, through, and out of solid barrier having no holes large enough to permit more than small fraction of the total leakage to pass through any one hole. Molecular flow occurs when the mean free path of the gas is greater than the longest cross-sectional dimension of the leak. The mean free path is average distance that molecule will travel before colliding with another molecule. Transition flow occurs when the mean free path of the gas is approximately equal. It is greater than, it is equal, Viscous flow occurs when the mean free path of the gas is smaller than the cross-sectional dimension of the leak. Transition ideal gas, frequent occurrence in vacuum testing, molecular flow. Viscous flow, occurs high pressure system, those encountered in detector probing applications. Laminar and turbulent flow. Laminar flow occurs when the velocity distribution of fluid in the cross section of the passage of orifice is parabolic. Laminar flow is one of the two classes of viscous flow. The other is turbulent flow. Particles in turbulent flow flows very erratic path, but particles in laminar flow follow straight lines. Choked flow. A sonic flow occurs under certain conditions, configuration and pressure. Assume there exists a passage in the form of an orifice or a venturi, and assume that the pressure upstream is kept constant. If the pressure downstream is gradually lowered, the velocity of the fluid through the throat or orifice will increase until it reaches the speed of sound. The downstream pressure at the time of orifice velocity reaches the speed of sound is called the critical pressure. If the downstream pressure is lowered below the critical pressure, no further increase of orifice velocity will occur. The consequence being that its mass flow rate is reached its maximum. Fluid dynamics. The equation of ideal gas is PV equal to nRT. P is the gas absolute pressure, V is the volume, T is the absolute temperature, N is the number of moles, R is Avogadro's number, that is 1 mole of gas always contains 6.022 into 10 to the power 23 molecules. Or less than 10 to the power minus 6 atmosphere cubic centimeter per second, the flow is molecular. 10 to the power minus 4 to minus 6 atmospheric centimeter cube per second, the flow is usually transitional. 10 to the power minus 2 to minus 6 atmospheric cubic centimeter per second, the flow is usually laminar. Greater than 10 to the power minus 2 atmospheric per cubic centimeter per second, the flow is usually turbulent. Acoustic method. The turbulent flow of a polarized pressurized gas through the leak produces sound of both sonic and ultrasonic frequencies. If the leak is large, it can probably be detected with the ear. This is an economical and fast method of finding gross leaks. Sonic emission are also detected with such instruments as stethoscopes or microphones, which have limited ability to locate as well as estimate the approximate size of the leak. So there is a instrument from 5 meters. You can understand there is a leakage turbulence because of turbulence flow. Smaller leaks can be found with ultrasonic probes operating in the range of 35 to 40 kHz, although actual emission from the leaks range to over 100 kHz. So actual leak is in the range over 100 kHz, but we are finding with 35 to 40 kHz probes. Flow detection, three separate methods: pressure increase, pressure decrease, flow, frequently grouped under three. Leak testing of pressure system using specific gas detector, static leak testing, dynamic leak testing. Specific gas detection device, remote control is possible, ensure safety of the operator. Leaks of approximately 10 to the minus 7 atmospheric cubic centimeter can be detected. The color of a halide torch, halide free gas, acetylene burner, halogen diode testing, sulfur hexafluoride detector, and mass spectrometer testing. A mass spectrometer is basically a device for sorting charged particles. The sample gas enters the analyzer where the molecules are bombarded by the stream of electrons emitted by a filament. The bombarded molecule lose an electron and become positively charged ions, which are electrostatically accelerated to a high velocity because of the analyzer lies in the magnetic field perpendicular to the ion path. The ion travels in distinct curved paths according to their mass. The radii of these paths are determined by ion mass, the magnitude of initial acceleration, and the strength of magnetic field. With a constant magnetic field, any group of ions having the same mass can be made to travel the specific radius necessary to strike the ion collector. The positive charge of the ions is imparted to the target or the collector. The resulting current flow is proportional to the quantity of ions of that particular mass. Okay. Leak testing, a constant temperature product. At a constant temperature, product of pressure and volume of an ideal gas is proportional to its mass. Leak rate is PV by time. Mass per time. Mass flow rate. Standard cm³ per second. Atmospheric cubic centimeter. The SI unit is Pascal meter cube per second. And in vacuum, torr liter per second. Fluid leak from higher to lower pressure. Real leaks, localized leak or discrete passage. Is a crack, orifice. Distributed leak. A leak due to permeation is also a real leak. Gas can flow through solids having no holes. This involves diffusion. Virtual leaks, gradual disruption of gases from the surface in a vacuum. The pressure reduced from surface gas is released from internal surface porosity, slags and grease and all these things. So this is something absolute pressure is gas pressure. This is zero gas. This gas, if you are putting a gauge, pressure gauge, so that is the gauge pressure, what is the reading is coming. So absolute pressure is gauge pressure plus barometric pressure. This is zero absolute pressure, full vacuum. So gauge pressure plus this, if 101.3 kPa, 760 mm of mercury, 14.7 psi, 30 inch of mercury. This you can say so this one at sea level. So general safety for personnel, hazards from airborne toxic liquid, vapor and particles, flammable liquid and vapors, electrical and radiation hazard, safety with tracer gas, precautions with compressed gas cylinders, precautions in pressure and vacuum leak testing, preparation of pressurized system for leak testing, exposure to toxic substance, leakage rate testing by measurement of pressure change in closed volumes require that of the system. Under test to be maintained at a pressure other than ambient atmospheric pressure change. Leak test can be made with either an evacuated or a pressurized test system. The leakage rate Q to be measured pressure change, that is Q is delta V delta P divided by delta T. The basic equation for pressure change leak testing used for comparing the two different conditions of given gas is PV1 by T1 equal to PV P2 V2, U1 V1 by T1 equal to P2 V2 by T2. If one is keeping constant, pressure constant, then you can write it P1 and P2 equal. So other things is remaining. So anything you can change this equation to something when B is constant or when T is constant. So you can write down and get other variable. is the histogram for conversion of vacuum absolute pressure between prior to unit of TER and SI unit of Pascal. One standard atmosphere is 100 kPa, 760 TER. Bubble test technique for detecting or locating leaks can be divided into three major classifications related to the technique of using the test liquid. In the liquid immersion testing, the pressurized test object or system is submerged in the test liquid. You see bubbles. In the liquid film application technique, a thin layer of liquid is flowed over the low pressure surface of the test object. The example of the solution film leak test is the well-known soap bubble technique. Plumber detect gas leaks. The foam application technique is used to detection of large leaks in which applied liquid foam from thick sorts of foam. When the large leak are encountered, the rapid escape of gas blows a hole through the foam, revealing the leak location. Bubble testing has the obvious advantage. Okay, this bubble leak test pressurize the interior volume of the test object or system before and during the leak test. Internal gas pressure should be applied across the pressure boundary before the test liquid contacts the external surface. Test to prevent entry of liquid into leaks, which might possibly clog the leaks to gas flow. Protection against hazards of overpressure must be provided. Control the heating of sealed test object and small components to cause internal gas expansion. This increases the pressure differential. Apply a partial vacuum over the surface. So this one is the third one. Apply a partial vacuum above the surface of the liquid. Immersion liquid or solution film. Partial vacuum reduces the external pressure to the pressure boundary. The increase in pressure causes gas flow through any leaks. Bubble testing has an obvious advantage of being relatively simple, rapid, and inexpensive. So disadvantage: contamination of test specimen, then you cannot understand. Improper temperature, there is problem contaminated or foaming test liquid. Improper viscosity of test liquid. Excessive vacuum over the surface. Low surface tension of the test liquid leading clogging of leaks. Excessive vacuum, it will just blow up. Cleaning liquid that clog leaks. Air dissolve in the test liquid of outgassing from the corroded test surface causing spurious bubble formation. Leaks with directional flow characteristics, intermittent or very slow leakage, porosity leakage. So this is a picture, vacuum box technique, providing pressure difference across the leaks in the local area of large test object. And for the corners, there is something like this. And the floors, something like this. That is air ejector. Example of vacuum boxes used for bubble emission. The vacuum boxes to fit special structural shapes. Helium tracer probe. So there is helium and system under test is evacuated. Vacuum, optional turbomolecular high vacuum pump. helium leak detector, auxiliary pump. So when you are giving this by tracer probe, you are sending helium inside this vacuum. From this vacuum, it is going to the helium leak detector. That is called tracer probe. You are supplying outside this vacuum system. Helium leak testing of evacuated vessel or system with tracer probe. This is vessel under test, helium under pressure, arrangement for sampling probe, sniffer probe. Sniffer means it is pressurized, helium under pressure inside the tank. Here vacuum inside the tank. You are supplying from outside cylinder. Here you are sniffing it, means it is directly combined with a helium leak detector. So this is called sniffer. In the helium tracer probe technique, the mass spectrometer leak detector is connected to the internal volume of an evacuated test object such as vessel or piping system, while a helium spray tracer probe is moved over the external surface to detect the specific location of leaks. In the helium detector probe technique, the test object or system is pressurized internally and the helium or gas mixture containing helium. The mass spectrometer leak detector is connected to a host scanning probe that collects sample of gas leaking from the external surface into the surrounding atmosphere. So this is called sniffer probe. Now it is about 10 to the power minus 7 PA per meter cube per second to 10 to the power minus 6 standard cm cube per second. Finding leaks 10 to the power minus 7, 10 to the power minus 6. So when vacuum leak testing by hood technique, figure 3, let us see the figure 3. So there is a hood, you supply helium here, and system object under vacuum, evacuated. This is hood technique, and this is object pressurized with helium for this small leak testing of sealed component internally pressurized with helium tracer gas enclosed in bell jar. This is bell jar technique. Hood technique of leak testing of evacuated components inserted into hood envelope containing helium atmosphere. The test cap with O-ring cell, helium filled test vessel, mass spectrometer leak detector, leak testing closure seal with evacuated envelope technique. So this is 4, 3, 4, 5. Okay, when the vacuum leak testing is by hood technique, the mass spectrometer leak detector is connected to the evacuated interior of the system under test. The test object or the system then placed under the hood or within a chamber containing helium gas or an air and helium mixture, usually at atmospheric pressure. This technique can be used quantify the total leakage rate of the system. However, it cannot be used to determine the specific location of the leak. In the bell jar test technique, the sealed component, where the test vessel is sealed with helium tracer gas inside and mass spectrometer evacuates the test cap over a closure welder gasket. This technique is similar to hood technique, except that only a section of the tested component is being leak tested. That is figure 4. Figure 5, bell jar technique. Component filled with helium gas mixture containing helium are placed in a evacuated testing chamber. The vacuum chamber detects helium leaking from the part. In leak testing, a large evacuated system, the accumulation technique increases sensitivity beyond that which can be obtained by dynamic testing. The evacuated object accumulated technique is also used in production of testing of evacuated components passing through a helium hood for a period of time. So these are finished. Will be very small questions, not too much. There is a fan to keep helium air mixture, test object under helium pressure, sealed room container, sampling probe, helium leak detector. So parts per million testing by accumulation of helium tracer gas and sampling probe test. Normal percentage of helium in the air is 0.0005 percentage. 5 microliter per liter helium. So this is in air. A proper connection of helium mass spectrometer between high vacuum pump and 4-line pump up leak testing of diffusion equipment and large vacuum system at pressure below 10 MPa, 0.1 mTOR, optimum operating pressure of helium mass spectrometer. This is the hood. So maybe 10 to the power minus 6 helium mass spectrometer. Spurious background, helium leak testing, spurious background signals helium contamination of the atmosphere surrounding the test object. Ion scattering due to gas pressure too high in the mass spectrometer tube. Hydrogen and hydrocarbon contamination of the mass spectrometer tube. And elastomic gasket, grease, rubber hose, painted surface and castings exposed to high concentration of helium tend to soak it up and become source of helium outgassing. So this is the outgassing, why outgassing is there. That is the spurious background. Sensitivity of helium mass spectrometer. This is helium mass spectrometer. Okay. The sensitivity is 10 to the power minus 12 Pascal per meter cube per second, or 1 into 10 to the power minus 11 standard cm cube per second. The leakage is so small that it could have take more than 1000 years for 1 centimeter cube of air to leak from a vessel pressurized at 100 kPa pressure gauge. But because this is helium, a helium mass spectrometer leak detector is a complete system for locating and measuring leakage into or out of a device or a container. This technique of leak detection is initiated when a tracer gas, helium, is introduced to a test object connected to the leak detection system. The helium leaking from the test part diffuses through the detector system. Its partial pressure is measured and the results are displayed in a meter. The mass spectrometer ionizes gases in a vacuum and accelerates various ions through the electrical and magnetic field. The helium ions are separated and collected, and the resulting ion current is amplified and indicated on an indicating device. So you get 1 to 10 to the power minus 12 EA meter cube per second, or 1 into 10 to the power 10 to the power minus 11 standard cm cube per second. So mass spectrometer, helium mass spectrometer is a very good device. Means it can detect much smaller hole, much smaller leak. That's all. So this is the mechanism: arrangement of 60-degree magnetic sector mass spectrometer. So this is the molecule, the leak, leak. The leak pump is connected here. So all this leakage coming here. So it is repeller. Then it is bombardment of electrons on this helium gas. Then helium become ion. The positive ions then move. Then there is magnetic field, object plate slit, magnetic south pole. So heavy ions, that is plus ions, is going to the amplifier, collector plate, amplify and output as a voltage. So this is the leak can be detected by this method. It can detect very fine leaks 10 to the power minus 11, 12 like this. Standard meter cube per second. Standard cm cube per second, sorry. And PA per 10 to the power minus 12 PA meter cube per second. Okay, thank you, gentlemen. This is leak testing. So